So, hey there everyone, I am Aditya. On behalf of my team, I am going to explain the project which we are working on is the movie recommendation system. Talking about movie recommendation, when we want to see any content online, we generally Google it or just ask our friends and relatives. But there are 50% chances that you may like it or not. Now you may see like movie recommendation system, okay, so what? It is very common these days. But what makes our project unique is the amount of accuracy which we provide. Coming to the problem statements which we are solving is building a movie recommendation system on dataset, which is movie lens. We'll talk about movie lens in the next slide. Talking about this, we want to combine aspect of personalization, that is genre, popularity, content, language, etc. Now talking about the dataset, the movie lens dataset contains 9,000 movies with 600 users and 100,000 ratings. This movie dataset is combination of IMDb dataset and TMDB dataset, which is publicly available online. This dataset is 80% training and 20% testing model based on user experience. What makes our project unique also is the user experience which we provide is very easy. Coming to the data analysis, the genre distribution can be seen here in the pie chart. The drama and comedy are very common these days. This graph shows the rating per user and same is the histogram ratings with the movie versus the people who are watching it. Talking about the models which we use, the popularity based model, content based model, collaborative filtering, matrix factorization method, combined model of SVD and CF, which we'll talk in the later slides, hybrid model. We're going to look at these models one by one. Popularity model. What does this imply is the genre of the movie which is computed mathematically. That is with the weight rated of IMDb and DMDB websites. Here we use a formula that W equals R into V upon V plus M plus C into M upon V plus M. The number system is named downwards, that W is weighted rating, R is average rating of a movie scaled from 1 to 10, and V is the number of votes for the movie, M being the minimum votes required to be listed in top, C meaning vote average. Now calculating the W, it helps us enhance the popularity model on the movie. Now coming to the action movies, animated movies, these are some of the part of our data sets, that the Dark Knight, Fight Club, Inception and so on. Animated movies contain the Lion King, Inside Out, Wall-E, etc. The W calculated can be seen here. The popularity as the same. Now content based recommendation system, where there are two types based on genre and the year of release, and movie to movie similarities. There is a system known as movie to movie similarity. That means if you are watching a science fiction movie, something like Harry Potter, the system will recommend you Marvel, because Marvel is also in science fiction movies. And talking about the genre and release of the movie, the genre can be horror, drama, comedy, etc. And there can be a combination of all the genres which our system will recommend you. User and item vectors. Vector of length total genre with 1 at relevant indices. We are naming the vectors like 1, 2 and 3. Action is 1, 0 and 0. Romance is 0, 1 and 1. Comedy is 0, 1 and 0. Similarly, user vector. Vector of length total genre with the value of average rate falling for genre based on rating in training sets. The user profile will contain two types of genres and vectors, that is 1 and 2. Action will contain 2 and 4. Romance will contain 4.5. That means the genre can be named as a vector. We are taking genre on the scale of 1 to 10 and naming it from 1 to 10 will help the user to understand that the movie is tilted towards what type of genre. Evaluation matrices. The matrices system can be seen here in the table. Movie to movie similarity, as I told, that TF-IDF using overview and tagline of movies. what makes is this just give movies with similar description. Movie to movie similarity can be of, for example, we take Doctor Who Last Christmas. The Doctor and Clara face the Last Christmas trapped on Arctic base under attack from the terrifying creatures. Who are you going to call? Santa Claus? This description can be seen similar to many types of movies like How I Ended This Summer, Santa Claus, The Spirit of Christmas, etc. This type of movie to movie similarity content can be also covered in the project. Improvement: adding the general multiple times to give more weightage, changing the TF-IDF to count vector. The TF-IDF gives lesser weight to frequently occurring terms across documents. That is, this model will analyze the description of the movie and see what terms of the movies are common in both. The lesser weight will be obviously rated late. Movie 1, 20 years after. This is a famous movie. In the middle of nowhere, 20 years from an apocalyptic terrorist event that obliterated the face of the world. This description can be seen similar to many types of movies like Wizards of Waverly Place, the movie, Under the Mountain, Born in Flames, etc. Now, as we look at the description of 444, Last Day on Earth, a look at how a painter and a successful actor spend their last day together before the world come to an end. Now it is interesting to note that apocalyptic terrorist event and world coming to the end, both similarly meaning same. That's why it is recommended in our system. User to user and item comparison. This can be seen like the graph of error value versus the similarity metric. Now these are inverse relations. If the error value rises, the similarity decreases, and vice versa. RMSE and MAE for different K. The RMSE value decreases as the K neighbor increases, and similarly the MAE value decreases and the K neighbor value increases. Latent factors method. Matrix factorization algorithm using surprise library. The SVD, baseline estimates plus latent factor prediction. SVD PP and SVD plus considers implicit ratings. Implicit ratings are the ratings which are hidden from the users. Hyperparameter tuning using grid search CV. Number of epochs, number of factors, regularization parameters, etc. These are all the models which we are using in the Python program. Evaluation of various algorithms. These types of algorithms can be used, and we are working on the major algorithms like KNN baseline, KNN with Z-score, KNN with means. Now coming to the RMSE and MAE things, the value will increase in such a way that algorithms accuracy can be seen here. The more algorithm we apply to the model to learn it, to teach it, and to understand it, the more accuracy will rise. Evaluation of different algorithms. This graph can be seen like precision, recall, F measure. Precision indicates how accurate and precise movie recommendation is to the user's interest based on popularity, genre, etc. Now NDCG scores for different algorithms. These are all types of data sets which we are feeding into the system, and the system will learn all the things based on our data set and will recommend to the user which model is best for rating less ratings and training data. Less than 18 ratings per user. For example, if a movie gets low rated, we ask the user to rate it in order to recommend it to other users. And if the movie is overly rated, it is directly recommended. The combined model. The combined model matrix factorization plus cumulative frequency. Weight linear combination of prediction ratings. We predict the recommendation linearly based on graphs, like as we saw here on the previous slides. Combine KNN baseline, SVDDP and SVD baseline only. Weighted combination of best algorithms. These best algorithms can be seen like RMSE, MAE, precision, recall, F measure, etc. The hybrid model. The hybrid model helps us to understand the prediction of the rating and the prediction of the recommendation system. Both go side by side. Combined model of SVD and CF, content based movie to movie similarity, and popularity model with user profile. What this means is we use the combination of combined model, we use the combination of movie to movie similarity, the popularity model, and the user model. The graph can be seen on the side that starting from the user will suggest top 5 movies which he likes. We analyze on the movie to movie similarity base and predict the rating based on the movie. Combination model and popularity model will act like same, predicting the rating and sorting the recommendation. Moving on, results when enough information of user. For example, if we have enough user information and enough information that the movie requires to be recommended, like this, adventure can be 4.17, animation 0, children 0. For example, this movie contains adventure on a scale from 1 to 10 as 4, which contains 0 animations and 0 child actors. Comedy, it is 4.2, romance, it is 4.5, drama 3.87 on the scale of 10. Now, a particular movie can be recommended on the genre, popularity, and many other factors which are listed here, that film noir, western, musical, etc. These are all zeros. That means that movie doesn't contain any type of genre related to this. These are some examples of, again, the movie The Dark Knight. The Dark Knight is sorted in the lists such as action, crime, drama, IMAX, etc. And similarly we have A Silent Voice, which is animation, drama and romance, which doesn't contain action like Dark Knight. So the action part will be 0 in that. Results when enough information, like the Matrix. Obviously we know the Matrix, action, sci-fi, thriller. So we don't expect any romantic genre to be present in the movie Matrix. Similarly, we don't expect any comedy from The Dark Knight, or let's say The Jungle Book. We don't expect any sci-fi action from The Jungle Book. It is a children movie. Now, when less information about the user is present, like the user hasn't provided much information about his likings or dislikings, so when that is the case, the accuracy will decrease, and that is why many things are 0 here, like documentary, IMAX, others, animation, children. The genre will become 0. For example, the movies like High Noon, 3:10 to Yuma, Spirited Away. These are all the movies which are underrated. There are less ratings available for the movie and less people have watched it. For example, the Black Mirror, it contains drama, horror, mystery, sci-fi, thriller, etc. So what do we take away from it? Like, what is the summary of it? The content based with genre is good when a user has less ratings. Obviously, when a movie has less rating, then recommendation is widely popular, where user will end up liking it. Movie similarity metrics based on features like overview, taglines and genre. Item to item collaborative filtering, as I told about the movie filtering. KNN based and SVD based algorithm will improve the global baseline added. These algorithms will improve the program based on Hollywood, Bollywood and many other movie industries of the world. Combining the prediction and recommendation of different models give better results in terms of accuracy and quality of recommendation. So the references which we use is from the surprise library, hybrid combination system and evaluation recommendation system, which we are combining it and making it accurate. So thank you for listening to us. We'll see you in the next one.